Okay, if I were doing this problem, and again, looking for perfect, there's nothing wrong with it. But what do I immediately know about the problem is it looks really simple to factor. And let me write down what I mean by that. If I were to factor that problem, just by simple trial and error, x squared, 16, 1 minus minus. Let me just check that out. What do you get? X4 minus 16 minus 1 is minus 17x squared, and you get plus 16. And even further than that, what you get is these are factorable. They're difference of perfect squares, and I'm seeing them all over the place now. And if you did that, you're done. I really mean that. You're done. It's right over here. There and there. All right? Now, what I'm going to talk about, a lot of people, they don't see that. They just say everything looks like the past to them. And there's nothing wrong with that. And what are you looking for? Well, you're looking for perfect squares. So a couple of things you could do, and I'll write this down for you. Kind of looking at it, you could say, oh, it's got to be something to do with x squared. Again, I'm looking for perfect squares. And then you're looking at the 16, and you probably say, 4. That would be minus. And if you did that, what would you get? You get x4. You would get 16, but then you get minus 8, and you need minus 17, so you'd have to put this down, minus 9x squared. And there's nothing wrong with doing that. Let's go through it. And what would you get over there? Well, you're going to get x squared minus 4 minus 3x. X squared minus 4 plus 3x. And by the way, I'm not opposed to putting that down as an answer. You did factor the problem. It's not completely factored, but you factored it, all right? So I want to point out, in the K, I have that answer written for you, and I'll point out where that is, right? So I do see this answer in the K. Now, by the way, it's not the best answer, but it is an answer. And the other thing you could do with that, I've always been doing descending powers of some variable. That's also in the K. I've done that before. Now, someone says, well, what did you do next? I factored, right? Because I saw these things as being easily factorable. And the way I saw that, once I put in order, I kind of see what it is. And what's that going to be? Well, I'm factoring this first guy here. What would that give me? X minus 4, x plus 1. And then I factored this guy over here, and what would I get? X plus 4, x minus 1. And that's where I'm seeing that over there. I'm seeing it, and I'm seeing this over here, all right? Now, let me just do another one. And someone says there's so many varieties, what's the final answer on it? This is actually the most correct answer. When I say the most correct, when people are saying factor, what they're saying is get it into linear factors if you can. All right, that's really the gold standard. Can you get these into linear factors? Well, x minus 4 is a linear factor. That means degree 1. X minus 1 is a linear factor, degree 1. X plus 4 is a linear factor, degree 1. And x plus 1 is a linear factor. All right? I want to point out, some of the people, they say, could I see these things being differently than the way you just did it? And of course you can. And let me talk about that. So if I were looking at this again differently, I might write down this instead, and I'll put it down for you. And it might seem crazy to write it down, but x squared, and I'm seeing that 16. Maybe I said plus 4 instead, squared. Now, what would that give you? Let's take a look at it. That would give you x4, certainly give you a 16, and then what would I get? I'd get 8. So, but I don't want 8. I want minus 17, so I'd have to take 25 away. All right? And then you do the same thing, right? What are you doing? You're factoring difference of perfect squares. Not that I'm going to belabor the point, but that's here, here. And then you start to realize, well, these certainly do look different, right? If you look at these two, they definitely look different. Like, I want to point out, if you saw this and you saw these up here, you would definitely say they look different. And that's why we like to go the complete factorization of the problem. They're going to produce the same exact factorization, right? And that's important. No matter what path we take, we're going to be getting the same exact factorization if we completely factor it. All right? Thank you.